Hello team, today's challenge is Pronic Numbers. Pronic is a weird mouthfeel trying to say it. Pronic. But the key to Pronic Numbers is that if you get two consecutive numbers, the factors of that Pronic number are back to back. So 2 and 3, right? 3 being 1 more than 2. So 2 times 3 is 6. For 12, it's 3 and 4. For 20, it is 4 and 5. All the way up to 132, which is 11 and 12, and higher. All right, it just keeps going. So those are our Pronic numbers today. We do have some falsies in here that we have to sort out as well, and we can do all that stuff. Now, when I started this, I thought, man, that feels a lot like prime numbers, right? Pronic numbers, not prom, right? But Pronic numbers. And prime numbers being very similar. So I went back to some prime code, right? Some code that used prime numbers, which is, in this case, June 20th, we had prime factorization, but there have been others. And usually that code looks like this. We have a loop and we do a math.square root on that and do some stuff. Well, my first instinct was to do exactly that. So jumping over here, my advice here is don't do what I'm about to, okay? Because there's a mistake. And I want to show it so that I can show that mistake and then make it better. So for the moment, just watch, right? Unless you like typing, then absolutely follow along, okay? But we have this for loop, okay? And it goes here and we create some space. The I needs to be 0 because that's where we start out. We still get the math.square root. Number is now num, and that is our loop, okay? Now inside of here, we test if I times I plus 1, just like this, plus 1. If that equals n, then return true, right? Otherwise, return false. Spelling it right, false, just like this. And it works, right? We can comment this out, see that things are failing, bring it back. But again, this, yes, it works, but it's not efficient. And that might catch people off guard because it feels like it should be, right? We've done the shortcut thing with math.square root and whatnot. But thankfully, somebody reviewed my code and pointed this out. So here's a little comment to help us out. So I'm going to drop it in here with something like 6. Okay, 6 is one of our tests. The square root of that is 2. Okay, 2, which means that, and of course the numbers that we're looking for are 2 times 3, right? So 2 dot something, and we're looking for that 2 times 3. For 12, it is 3, the square root is 3 dot something, right? 3 point something. And we go 3 times 4, right? And you can hopefully start to see that pattern where 20 is 4 dot something, and we get a 4. 132 is 11 dot something, we get 11, which means, right? Hopefully that's making sense. But it means that the loop does nothing for us other than slowing us down, right? That's the key to this loop. It does nothing because in the grand scheme of things, we always go to the end of the loop, which means that for 132, we loop 11 times just to get the number 11, right? For 6, we loop 2 times just to get the number 2. We only enter this on the very last possible loop, which means that the loop is kind of useless in this case. Instead, what we could do is we could grab all this, just bringing it down for a second, okay? And we can get rid of that loop. So let's get rid of this part here, okay? And start again. Now I'm going to name this I, okay? So I was up here. I'm going to put it as down here. If we were doing this in real life, I is a terrible name for this. But I want to be able to show you this I versus this I, okay? That's the whole thing, okay? So jumping around, my cursor, putting it back. We have math.square root just like this for that n. And if you're looking, right, we don't care about the decimal. So if we just floor it or truncate it, then we get exactly what we need. So wrapping this up really fast, we go math.floor. Great, okay? And then what do? Well, we return all of this. We return the conditional because it's already doing true or false already, right? So we go right here. Again, we can do that. If I comment this out, we throw an error. If I bring it back, all of a sudden we're down to 2 lines, right? And it is quite a bit faster because we don't go through all the steps in the loop. We don't have to. We already get that information from this math. Now, again, it works quite well. And there's only really one last thing to do, which is a couple interesting things about Pronic numbers. The first being that Pronic numbers, all Pronic numbers, are positive. They have to be, right? If you do something like 2 times 3, right? 2 times 3 is 6. If you change these to -2 times -3, right? Because those would be consecutive. Well, -2 times -3 is also +6, right? 2 minuses make a plus. And so there's no way to get to a minus number because it would have to be -2 times 3, sorry, -2 times 3, or 2 times -3, right? One of those would have to be positive and one of those would have to be negative, which means that they aren't consecutive. Okay, so all Pronic numbers are positive, which means that we can shortcut this a little bit and go, if n is less than 0, return false, right? That saves us. It's still doing its thing. It's still good. The other thing that's interesting about Pronic numbers is they are all positive, or they are all even. Sorry, this is the positive, but they are all even, right? Every time we multiply 2 numbers together, we get an even number, right? Which is kind of interesting for Pronic numbers. I'm not sure if that's the case for everything. Math is eluding me right now, but we can shortcut it again, okay? And we can go something like n modulo 2. If that is not equal to 0, then return false. And so by doing that, we do a comparison here and shortcut having to run through all this math just to return false, right? And that's going to save a lot of work, right? Because 50% of all even numbers, or 50% of all positive numbers, are odd, right? So we can just discount them right away, okay? So very interesting stuff there, where all Pronic numbers are greater than 0 and all Pronic numbers are even, right? And if we get past that, then we didn't need a loop. I thought we did, right? When I started, I thought we did, but we don't. We can just use some of that information that we would have used in the loop and output the final result, right? So a little bit of an interesting thing here. Again, I wanted to show this because sometimes I go down the garden path too, right? And that's okay. That's how we learn. If you did it a different way, if you want to share that, definitely do that. If you like this or hate this, or if it didn't make sense and you'd like me to explain it a different way, hit me up in the comments. Again, not every solution, just hopefully one good solution, right? That's what we're going for today. And yeah, this has been Pronic Number, and I will see you tomorrow.